So I've worked with many organizations in and out of academia, but I've also used science to help shape policy and practice. And that's really, I think, led to my emphasis on sort of knowledge exchange, but also around how do we, the latest IPCC has said, for example, we have enough science, we have enough evidence, we just need to act. And so at what point, yes, we continue to need more science. We've been talking about these second stage coastal resilient calls that we're just finalizing the bids on today. We need more science, but we also need to apply the existing information that we already have. And that's really what I'm going to talk about today. And I think some of that requires us to rethink how we deliver and do our science or our research as part of a portfolio of work. So how many of you are familiar with the diagram on the left? Would use it in teaching, for example? Some of you not familiar. Basically, these geochemists largely came up with this phrase called critical zone science in the early noughties, and it was really designed to try to see the landscape in a particular size, to see it from the top of the treescapes to the bedrock. So kind of an intelligible space of a division of the earth that people in theory can understand. And then that was morphed against sustainable development goals by research funders. And so the ask for these China projects was to look at these degraded landscapes. How do we then help better deliver sustainable development goals within this context of the top of the treescapes to the bedrock? And there's an enormous project of researchers, 5 projects funded across the UK and China, 4 regions of China. And the science was done in a very traditional sense, where there's a set of questions that were conceived around particular problematics. In this case, nitrogen was one of the things that was consistent between the projects. And they looked at deep nitrogen in terms of the lowest, and in terms of the karst. There was 2 projects looking at it in terms of the soils, and in terms of what David was involved with, and myself was looking at it in terms of in the biogeochemistry in the water in these systems. It also looked at the red soil system. Now, all of these study sites had similar environmental challenges. They all had fertilizer overuse and pollution of the water and of the soil. They had erosion issues in most of the locations and water abstraction issues. And there was some known contamination issues in advance, particularly in the peri-urban context. But one of the aims of the project, because it was Newton funded, was how can we better achieve sustainable development goals? And part of the premise of the framing of the research was, has the environmental policies that the Chinese government put in place to deal with land degradation been effective? But there was a specific emphasis on poverty alleviation, improving lives of local people. And I was brought in because I was a NERC Knowledge Exchange Fellow at the coast, to then look at how do we think about what the people on the ground know, the farmers and these impoverished communities know about their landscape, and what are their biggest pressures, and how can we marry that with the science. And so we spent some time initially asking, what are the experiences the scientists have of knowledge exchange, both in the UK and in the Chinese context within this large group of scientists. So managed to produce a paper out of that, but looking at these differences in approach. And even now, when I spoke to Peking last week, they're still very much at their infancy. They don't have to do knowledge exchange in the same way that we do as part of their research portfolio. They can still be, doing blue sky science most of the time. But what we ended up doing is a bit like Tony. It was interesting. I was speaking to you over lunch, how we'd become using social science techniques. We ostensibly did the same thing. We said, right, we can't actually go in and do knowledge exchange because we need to know, what do they already know? What are their biggest pressures? Who do they learn from? And how receptive they are, and how much capacity do they have to learn alternative farming techniques? So we did a series of interviews and questionnaires of these people in these regions of China. And some of the things that came out was that there was key challenges were fertilizer use and water. And we also asked the scientists on the team, what kind of questions would you be interested in knowing from the farmers? And this is a paper that David led on. But what we didn't do was have a human geographer or a social scientist in the bid, because it was a science project. It was NERC funded. So these new interdisciplinary calls are wonderful because you're actually able to start as you mean to go on. But what we did is we applied this concept of social capital to the data that we did derive. And we started to look at what kinds of bonds and bridges and linkages were there, and did they vary between the regions? So therefore, would your knowledge exchange or the type of science you do change between these different regions? And so what we found is that there were geographic variations between regions. And in the first region that we started the work, where the project with David was, overwhelmingly people learned from family. This was the poorest region of the poorest province of China, but they interestingly had zero connection to any researchers or experts. Whereas Chengwu, which was in the lowest plateau, there was a much more pluralistic approach to learning, and they had trust with many more groups. They had linking and bonding networks, not just familial networks that were part of their social capital. So there's something different going on that's shaping how the willingness and the capacity of farmers to learn from others and vice versa. And this is a paper that just came out in September. And so we found that these linking networks were largely absent. These could be strengthened, and that there's the like catchment sensitive farmers we have in the UK. These agrotech officers are starting to fulfill that void. But we also found there was differences between what the government said that how the farmers should be trained, how they like to train them, and how the farmers wanted to be trained themselves. So it's a really important to actually get to the people who are husbanding the land. But one of the things that's interesting about all of this, notwithstanding the research in and of itself, was that critical zone science, I did a retrospective in 2020, and human impacts on the landscape were not mentioned. And when I was producing these pair of papers, and we've had our own EOS blog, Simon Curley at NERC said, I remember going to America and the critical zone science didn't even want to include ecology in their discussions. And you've taken this another whole step further. And Bruno Latour is a recently deceased French theorist that a lot of human geographers read, and he found that the critical zone was an excellent scale by which local people could understand and make sense of the landscape and hold it together. And so this readily understandable human scale narrative. And so what we did is we added this social science and this human geography. We tried to start to understand social capital, but in doing that, which is obvious, but the humans are these lived inhabitants shaping these CZOs. But importantly, some of the science didn't make sense. Scientific results didn't make sense. And by talking to the local farmers, the scientific interpretation of what was going on in these messy human modified landscapes changed. And ideally, we want to design the research with them. So if nitrogen and fertilizers are the greatest pressure, then let's think about studying it in a way that can support them in really determining, well, how much can I reduce it to improve my livelihood? And so one of the things that this tacit and local knowledge was really important, because the conventional wisdom in terms of natural landscapes, so that block diagram is natural landscapes, is that cesium levels increase as you go downhill. Cesium 137. And what was happening there is that the data didn't show that. These are heavily degraded landscapes, and basically the farmers were literally manually shoveling soil back uphill and filling in these cracks to sustain their livelihoods. That then warped the data pattern. And so we managed to kind of bring in a cartoon diagram about these interactions into a publication to illustrate the need to understand and contextualize your scientific results in these messy catchments, these human modified catchments, with not just scientific theory, but with local understanding and local practice and resilience of place. And the main reason I wanted to get this paper published is I wanted to change that diagram, because the 99% of the world looks like the diagram on the right, not on the left. And all the framing of critical zone science, all the teaching of it, is all framed around the natural pristine system, which very rarely exists in the world. And so that's the sort of big conceptual advance, of saying we need to rethink how we approach studying these sorts of systems. And one of the things that we also did is that we need to change how we fund things. So even now with these interdisciplinary calls, the research is going to be simultaneous. So you were just talking about your proposal around water quality and bringing the communities on site, but is water quality the most pressing issue for them? is that the thing that they will hook onto? And so actually, it's likewise with our proposals about waste and legacy waste. It's probably not the most pressing thing for them. So pre-project, pre-scientific project, you need to actually do some social science, and we need to fund that first. And so we've created a blueprint for how we fund and which parts are research-led, which parts are practice-led, and which parts are co-produced, with a view of potentially shifting funding models to become more reflexive of different ways in which you can incorporate different forms of knowledge. And importantly, we've differentiated the social science research from knowledge exchange research and knowledge exchange practice, because they're two different things. And they often get amalgamated together. And so we come up with this kind of concept of this human modified critical zone, where these traditional processes that scientists have very narrowly conceived are disrupted by these human activities, where these local people are showing resilience, but that's modifying the scientific results. And that we really need to train and research in ways that directly supports delivery of SDGs for local people. And so one of the other pieces of work that came out of that was Sarah Buckerfield's PhD that was based at Stirling, and it was to do with E. coli, and the greatest E. coli levels were actually the villages themselves. And so actually it became it's a public health management as much as the agricultural management of the water buffalo. So both things needed to be at play. And we just need to rethink how we approach studying these systems. And if we really are genuinely interested in delivering SDGs, how do we design our projects so that that intent is there properly from the outset with the local people who are going to best benefit from improving delivery of SDGs. So, anyone have any questions on the kind of agricultural part of the talk? I did that very fast. Anyone? No? Switch gears completely is to the coast, which is where the bulk of my work is. And one of the things, how many of you have seen this graph from the latest IPCC? This set of graphs? Yes? So there's something really important about visual communication. It goes back to the previous diagram, like how we visually communicate. So if we look here with the old diagram, it didn't visually communicate very much about what was going on in the landscape and what was driving landscape processes and change. Likewise, this new IPCC diagram is excellent, but it's a little bit too subtle. So top graph, temperature. B graph, sea ice. So you're getting an inversion. The September 2023 data is off the charts, right? It's like way up here. It's way down here. This has ocean surface pH. You could flip that and have another one, which is so they've got ocean temperature. So that's the other one they could have put there instead, right? Instead of pH, they could have put ocean temperature, which is an upwards trajectory, which is perhaps a better one to put with sea level rise, in terms of if you're talking about how the temperature changes relate to sea level rise. But the bottom one is the one that's important. So this, you can read like this, but it's designed to be read across and up. And that's what's too subtle. The gray is too subtle. On my screen, it's light gray, but it's really not done well enough. It took a while to really appreciate that. So, and you really need to go back. Prior to 2021, the first time the IPCC plotted sea level to 2300 was in the special report on the oceans and cryosphere. And that graph is quite scary because it basically just plots up here to 3 meters. And it's maybe more effective than that graph, or almost needs to sit alongside that graph. Because what it does is the rise that we're projected to 2100 is like really shallow as an exponential curve compared to 2300. It goes up. What this graph is trying to show is that sea level rise greater than 15 meters cannot be ruled out. The graph is all of it. And both the blue, the shared pathways rather than the RCPs, because they've changed the names, both the blue and the red, we're looking at least probably 2 meters, if not 3 meters of sea level rise by 2300. And judging by the fact that this year we're off the scale here, we're off the scale here. Marine heat waves are also not included in that graph. We're looking at a majority of flood risks, for example, we map and model erosion risk in Scotland is to 2100. We're designing buildings and housing and making decisions on land at the coast now for a very, very small amount of that uplift in that diagram. And we very quickly need to visualize that back. We need to help people understand that this may be uncertain whether we'll get 15 meters, but what's very certain is we're going to get well more than 1 meter and more likely 2 to 3 meters by 2300. And are we designing new cities and towns and any sort of infrastructure now to be viable in 2300? That's only, not 175 years away in the life of Scottish cities. That's very young. Are we planning for that? And so we're already locked into a certain amount of sea level rise, even with net zero, which sea level rise will still continue because of the hysteresis and the lag effect. So we need to achieve net zero because that will hopefully put us on the blue path. So it's not quite so challenging. So obviously there's all these environmental hazards associated with these kinds of events, and there's huge societal impacts, as Storm Babette has shown us. And Storm Babette has had coastal impacts, but they've been less. They've been sort of dwarfed by the flooding impacts. But actually, City of Edinburgh itself has had £150,000 of repairs. The last 10 years, their budget has shrunk to £30,000 of maintenance a year. The previous big storm in 2010 was 700k of funding. That 700k of funding was taken from other things, from leisure centres, from parks, from other services in the city to subsidise those repair costs. And so we haven't done the societal impacts just of Babette and Christina just on the east coast of Scotland are much, much higher than that. So we tried to get letters of support for these bids, and some of the local authorities, they're just an emergency. They're just repairing, emergency repairs to structures. And so we need to start to think proactively about how we plan ahead for this. We know the storminess is coming. We know the sea level rise is coming. Are we preparing ourselves for that? How much more science do we need before we need to change our decision making? And what is our role as civic universities in delivering more paper outputs versus delivering practical change on the ground that will make a difference for current and future generations? And so I was involved, fortunately, in the Dynamic Coast project, and aimed to strengthen evidence. It was very scientifically based. But we also developed the adaptation framing for this. And there's not a lot of words in it, but a lot of time was spent carefully crafting those words around, intergenerationally just, future smart, flexible decision-making now. There's all sorts of language that was carefully molded to think about making sure we're designing for the future when we take these data sets and use it to inform decision making. And the first Dynamic Coast it was published in 2017, and the second one in 2021. The second one did future look, but there was already an uplift in the rate of erosion, the amount of transects of shoreline change around Scotland between just in those few short years. And one woman I spoke to about these bids were putting together, there was 6 meters of coast that disappeared overnight. Along the Angus coast. But we've got a lot of assets within 50 meters of the coast, and importantly, those assets are protected predominantly by nature. If we want that nature to continue to provide that protection, what does a salt marsh sand dune system want to do as sea level rises? How does it maintain resilience? Anyone a coastal specialist? I know Carlos is no longer here. It wants to migrate inland. Right? It needs to move. to keep up with sea level rise, or else it'll get eroded away. So the boundary between land and sea is dynamic, hence calling it dynamic coast. And you come with one message from this lecture is that it's not a coastline. We have to measure shoreline change and we have to draw lines, but it is a dynamic interface and it's getting far more dynamic. And so in order to continue to afford this level of protection for large numbers of assets in Scotland, we need to create space for that nature. And that requires us to reimagine our land-sea boundary. And if we put these together for COP26, but basically if we have high emissions, the amount of transects eroding, the percentage increases a lot, and the meters distance inland doubles by 2100. So we try to make the link between adaptation and decision-making now and erosion risk and net zero. Because the difficulty with adaptation is it's second fiddle to mitigation. It's had much less emphasis. We're committed to a certain level of sea level rise. We have to adapt, but it's not going to create green jobs. It's going to reduce losses and damages. It may create green jobs in terms of, say, nature-based solutions, but it's quite a different narrative to government than it is net zero. And we also mapped social disadvantage to erosion for the first time. So we overlaid these data sets with social data to understand, is there a social variation, as has been done for flooding. But that's the first time that was done in the UK. And dynamic adaptation pathways, presumably most of you may be familiar with that concept. It's this notion that we can kind of choose different routes and have different timings of triggering of different actions. But one of the things at the coast is, regardless, there's new papers out by some of the world leaders in adaptation pathways. And, you know, ultimately all pathways end up in the future with retreat. Because if we're going to get 3 meters of sea level rise, most of our cities and communities will not be able to be in their current geographies. And so we need to think about, are we maintaining erosion and flooding? Are we resisting it? And where can we afford to do that? So that's Hurricane Fukushima response. That's the bus, that's the height of the wall, and that's the sea in behind. People are living in a fortress. Is that the kind of world we want? Can we afford that? Can we start to use nature-based solutions? So this is in New York City. They're talking about dry line. You'll see later we've helped the city of Edinburgh start to do that kind of thing. But we have to accommodate erosion. If we want nature to continue to protect, we have to make space for that erosion to happen. It's a natural process. And for that flooding. But we have to make space for that to function. And so you've got these 3 times as many assets are protected by nature, but we need to create space on land now for these natural assets like beaches to roll landward to continue to afford that protection to society. We can do things where we decide to put hard structures. That's where I spent the morning. Tony kindly got me in office because I'm co-chair of guidelines from Syria on enhancing hard infrastructure to enhance for biodiversity. So where we do decide to put hard assets, they don't have to just provide one function. So I'm going to skip through. I can talk a bit about this. So my knowledge exchange fellowship was about building capacity and how can we build in some of these ecosystem-based approaches, but can we come up with a roadmap to support implementation? Because we have a lot of adaptation plans, but we don't implement very well. There was a whole series of tasks involved in this process. And one of the things that we did is we started to work with, in this case, the Clyde Marine Planning Partnership to change the framing of the policy. So we wanted to consider the coast as a unit and adjust the zoning and development vision for coastal areas. And we want integration of shoreline management planning into land use planning. We're supposed to be doing that already, but we haven't been. And so what I did is also start to think, well, conceptually, what's getting in the way? So I worked with local authorities in England and 2 jurisdictions in England as well as in Scotland. And one of the things is there's policies that are preventing us in terms of their framing from making proactive adaptation decisions. So in England, it was an area of outstanding natural beauty, and you weren't allowed to build any more houses or develop buildings at all. A farmer had lost half their land since the 1930s. They wanted to build some holiday cottages to have an income. The holiday cottages are designed to retreat as the coast retreats, and literally all the services are above ground. You literally could pick it up like a crane and move these, like, the quite Scottish vernacular architecture kind of holiday cottages, and they just couldn't get permission to put them in. And so come up with this concept of adaptation windows as these collective individual decisions that can either enhance, i.e. create space for the future for that sand dune to retreat, or reduce by choosing to continue to build to the edge, decisions that would allow us to be proactive to adaptation or maladaptive to adaptation. And this concept is being applied in Sweden and elsewhere in Canada as well. But every time we make a decision around that interface of the land-sea boundary, we're choosing things that can kind of create enabling conditions that make strong, positive, proactive decision-making, open windows at the bottom, or weak decisions that close or narrow the adaptation space. So I was really pleased in China that they've created they've stopped 2 years ago, they've stopped the ability to reclaim land. So they've shut down a major maladaptive pathway, and there should be no more reclaimed land in China, and reclaimed land is built on. So that's a good example of making a decision that closes down something that's maladaptive, but they've also opened up a new set of policies that require land-sea governance, which should create more proactive space. But sometimes these opportunities are time limited. So our response to storms Babette and Christina are largely maladaptive. We're patching, repairing, we're just fixing, we're making things work again. We're making things safe again, which we might need to make things safe again, but it might not be the best long-term decision. And so one of the things, there's lots of different windows of opportunity, but post-industrial cities. So the foreshore of Dundee, they've transformed, they've put, the V&A there. Is that climate resilient to 2300? Is that the best regeneration plan that Dundee's had? Or are they storing up difficult decisions for future generations? And so this is the Swedish paper that's starting to use this approach. And they've used the windows approach to frame their decision-making with local communities. This city of Vancouver, Canada, where I come from, all of those plants that look like weeds are salt marsh plants trying to grow in that space because they created hard structures. And you roll forward to 2010 for the Olympic Village. Now those apartments may need to move, but the foreshore is designed in the way it can get wet, it can change. And we need more of that kind of very natural, very fluid, not expensive to lose and change in the future. And one of the things when we worked in Cornwall, which is where the windows concept came out, was David Cameron stood up in response to 2013-14 storms and said, we will rebuild. And he undermined all shoreline management plans that were non-statutory at the time, because basically the non-statutory planning in one location, the road got washed out. The non-statutory plan said, in this time epoch, we will not rebuild the road. We will move the road. But they didn't have any of the land bought, procedures in place, community consultations done, nothing, the groundwork wasn't laid to turn that storm into proactive decision. And that's really where we need to be going. We know the storms are coming. We need to be ready for them in a kind of practical sense of responding to them. And so one of the things we've done with my fellowship time was to spend time with Adaptation Scotland. And at the time they were finishing Edinburgh Adapts with them. And Edinburgh Adapts had been through every form of consultation and consultee, and none of them saw Edinburgh as coastal. Probably because of its history, because it was a village that then absorbed things like Granton and Portobello, but they had no coastal action. So we added 2 coastal actions: strengthen evidence, adapt our urban footprint to accommodate a dynamic and changing coast. Embarrassingly, they added another action at the coast, which was to maintain the existing structures, and nobody caught it, and they were conflicting with each other. But 34% of the political boundary is the coast. The blue line is the coast. Majority of it's artificial. that means it's unconsolidated, soft, at risk of erosion. So it's naturally made up of soft sediments, and there's very little natural beach and amenity, and there's huge numbers of buildings have been built in places that would be at risk or would be eroded if there was no defenses. So we've created a space that's very difficult to manage moving forward. And so this is just a good diagram of the made ground. The X is where is the corner of the wall. So in the 1890s, it was still a natural beach system. And all of that purple is artificial main ground. Some of that is quite polluted as well, that particular space that underneath that recreation ground. Along this is the sewage works down to Portobello at the bottom of that picture. And this was just some of these damages from 2010, but the standard of these defenses is low. They're going to need to be renewed. So do we renew them in the same place? Do we renew them somewhere different? And although we managed to change the Edinburgh Adapts, and although there's the Climate Change Act was in place, this draft of the city plan had earmarked that area from Leith to Portobello, which currently has the bus depot, car dealerships, the dog and cat's home. The dog and cat's home has a sea view. None of it needs to be at the sea, right? None of those particular things. To change it into urban area, housing-led, mixed-use redevelopment right to the coastal edge. This was in the first lockdown. I had a 5-year-old and an 8-year-old. I was exhausted. We stayed up until stupid o'clock in the morning to get this consultation draft in, because it didn't even mention the coast. It didn't mention sea level rise. It mentioned flooding, but only in relation to rivers, and that's because the flooding has dominated the problems the city's had until the storms this winter. So the key risks for a coastal city were not present. And national legislation was not being adhered to. So we suggested rewording what they'd already done for the rivers part to the coast. And we made a case as to why this would be beneficial for them. So suddenly, I'm trained as a geomorphologist, having to tool up in all of this legislation, because I had to make a cogent argument to them as to why it was important for them to include this in their documentation. At the same time, we were working with them and we were downscaling dynamic coast, because one of the problems with dynamic coast is if you've had, so this was a meadow. It was a meadow that's just above high water. But it would have been wetted even then, probably in storms. But basically that has become fully land. And so we used data that we'd already developed for SEPA on underlying erosion susceptibility, so semi-quantitative information, because a dynamic coast 2 and 1, if you've had seawalls as long as the OS maps, suggests there's no erosion. It's not no erosion. There is no erosion, doesn't mean there's no risk. There's actually quite high risk. And so how do you convey that? And so what we did is we tried to develop a methodology by which we could start to say, well, where do we think this might go? And where there wasn't walls for some of the time, some of the modeling was able to be done to say this is where the beach would go with time, to start to look at erosion into the future. So that science was useful to support these conversations with the city, but we've managed to get the city plan that proposed 2021 and is now enshrined in law. Erosion is firmly mentioned, and they're putting in a coastal buffer, which is fantastic. So it's a really, really positive outcome. And alongside that particular Leith to Portobello stretch, they have said, we will have a constraints plan. So in terms of where does the science fit, you need some of the science for evidence, but you then need to go into these planning domains, all these conversations. All that effort is probably worth 2 or 3 scientific papers, but that alone is not enough for an impact case study because it's too small and local, and can't be directly tethered back to us. And then now there's this constraints plan. They're going to have to model and really assess flood and erosion risk and what is the geomorphic effect of letting that bit of Edinburgh go potentially, so the science can come back into this process. And so what we did is we created these scenarios that were about resisting erosion, accommodating erosion, and being more transformative. This is that same bit of North Edinburgh where the wall was this used to be in the sea. And here they didn't reclaim this one pocket beach. And funnily enough, it's eroding. Funnily enough, they're going to have to put some defenses there. Unfortunately, so this is really positive news story, but it's not perfect because along that road here are key services. Internet, water, utilities, and it was too expensive to move them. So they've made a really good decision, you'll see in a minute, but they've not dealt with the difficult problem of moving the services now, nor have they put an easement in the design for future moving of those services to future-proof it. So they've made some big strides, but it's still not perfect. But these data were actually quite useful because this is the area that will erode in the erosion vicinity predicted. And that would be magnified along this whole stretch of coast. It's just you can only look at it in places where haven't been walls the whole time. And so, yeah, that's fine. And so one of the things that we also did, I had another project working on green infrastructure and greening the grey, and we brought in an environmental economist, and we said, okay, what's the cost of maintaining the current light industrial use, changing it to mixed use housing, or implementing a coastal park? And as you can see, the park is far more expensive than maintaining its current use, but there was a massive savings in terms of long-term benefits. But we were supporting the local authority in their decision-making by bringing this environmental economics appraisal. And so what they did is they took this original plan here, and the alternate plan was to create the park. And some of the data that was really important was when they added wave overtopping to flood risk. So one of the problems with SEPA's flood maps at the moment is they don't count wave overtopping. They're just starting to do that, which is great because the numbers of assets and the amount of land from the blue to the red is quite remarkable. And that's only to 2100 as well. That's not even further into the future. And so this is this bird's eye view of this, or sort of cross view of this geography. It's this area that they're looking at changing to the park. If they didn't put in the park and they put houses to the edge, the seawall would have to become the height of my student. And it's how do we visualize this and represent this in a way that the public can understand? And when I showed actually Alistair Rennie at Adaptation, the head of Dynamic Coast, he said that's one of the most important slides I've seen in the year, because you've actually shown what that will look like and you've humanized that. And so the park, fortunately, was improved in 2023. It is this good example. It's seen as innovative financing for adaptation because it was within a housing development, redevelopment, largely social housing. So the trade-off is fewer social houses are being built, but they're being built further back in a more climate resilient location. And importantly, we managed to get this diagram through the city council, which shows the potential proposed park, but also in the future that we can lose some green space to blue space. And we can start to show that flexibility of that edge. So sometimes there's happy accidents with our research. So I had this research on green infrastructure, I had this knowledge exchange fellowship, and then they sort of very much came together because a lot of the things we can do in the short term is change our land use to provide green infrastructure as a buffer to then buy time for future decision making and not commit ourselves to too many more hard structures and defenses that need maintaining, or indeed houses that need relocating in the future. And so this greening the grey infrastructure is what I was meeting with this morning, but it's really saying we need natural systems most, we can prompt recovery, but in these urban spaces where we do decide to put walls, how do we make them more multifunctional? And so they produced this first UK synthesis of this, and we're starting to collaborate and scale it up. So we've taken research that started as small little test tiles, and they're now, we've now got the largest installation of 2 kilometers of seawall that now has texture based on UK science. So you can lever change, but change takes time. So that first PhD started in 2007, and that wall was built in 2020, 2021. So it's a steady, process of change, really. Main things to take away. It's not a line. And we need to think about really how do we use what we're doing to help make, help support people who are making climate resilient decisions, make them as resiliently as they can, and as far into the future as we can, I would say. And the other thing is that this Knowledge Exchange Fellowship, at the time with the City of Edinburgh, I have a whole tranche of research now on urban coasts and urban beaches, and that all came about through discussions with the city. So these interactions can be really fruitful for generating new research ideas. But we need the time to sustain those relationships, and our university system needs to allow that, because it takes a long time. But you also have to be flexible and agile and be willing to let go of some of the science. So the meeting this morning about these guidelines said this is not robust. They're not robust. This is not academic science, an application of academic science. This is science around ecological enhancement moving into the practice domain, and all of the practical constraints of constructability and buildability and community decision making all are brought to bear. So we have to be flexible and agile about what we expect, and most impacts occur long after your work ends. So my KE fellowship ended in like 2018, 2019, and those changes the City of Edinburgh are in 2021, 2022. So there's a really long timing afterwards. So does anyone have any questions?
What would you say is, like, personally for you, coming from the hard science, moving into the social science, into policy, what's like one of the main skills that you've gained, or kind of like a takeaway lesson you've learned bridging that knowledge?
Yeah, it depends which one. I suppose it's, you have to learn to understand the drivers and the pressures that the other people are facing, and what resonates for them. What do they need? What will help them deliver their job better? And if you can help them do that, and be sensitive to the pressures that they're under, and not too expectant that they have time to read any research, and B, necessarily even want to incorporate it. So you need to kind of spend a lot of time feeling out, where somebody's at and where you can contribute, I think. So it's all people based. Did you have a hand?
Thank you. Thanks for that talk. It was great. I have a question related to time and decision making. Have you gained any insights into ways we could perhaps make decisions occur a little bit faster when we're in a very urgent situation, when perhaps it would naturally take a lot longer, but we perhaps don't have enough time?
Yeah, that's a real challenge. So, I was supposed to do more work on my fellowship with Glasgow than Edinburgh, and Glasgow started their adaptation planning process, and then it all got derailed because of the climate emergency, and that entire team was pulled from adaptation planning to climate emergency because there wasn't enough resource. And so it is a big challenge. We have this strategic program grant at the moment where we're working with Glasgow City Council, and unfortunately for the program, our program is out of sync. This is just my personal feeling. You don't want this necessarily going on the web. There's these windows of opportunity, right? And some of the windows are time limited. So we're having to my work package is involving flood modeling and then looking at implementation, and we're having to change what we've planned to try to meet this time scale. Because the planning cycle is happening at this pace, and we're trying to feed into it. And so that's sometimes you're trying to feed into an existing time scale, and that might lead to more change. But equally, the time scales sometimes have their own, there's lots of good reasons why things take time within government as well. And so it's appreciating their pressures and figuring out what is achievable and what is achievable now. So there's some big discussions in this guidelines that I'm producing around biodiversity net gain and how much do we mention that and how does that get referred to? And the sort of decision is that such a moving landscape that we don't want to commit in guidance now other than to be mindful of it and take account of it, but not be prescriptive, because that will allow the guidance to have the longest shelf life relative to this changing policy space. So sometimes it's figuring out how you situate what you're doing alongside something else that has a life and an engine and a process all of its own that you may or may not be slotting into or sitting alongside, if that makes sense. Anyone else have any questions?
I had a question. So earlier on, you were kind of talking about, I guess, some of the decision-making process, and they just phrase it in health and ecology research. There's a lot of discussion about in Glasgow. It was famous, this report that said we need to just let the city die, as being this kind of post-industrial sort of policy approach, basically, that it wasn't worth saving the city, which is part of the reason for some of the health inequalities in the city. How do we make, I guess, a more democratic process of having those conversations about what areas have to be left and have to be lost and which ones don't, so there's not those conversations happening behind, walls that we don't have access to until many decades later.
And that's particularly at the coast, that's a challenge, because the 1949 Coastal Protection Act, if there's one piece of legislation that needs to change, it's that one. It has not changed since 1949. And it pushes erosion onto local authorities and flooding onto SEPA. And so there's two levels of governance managing things. And so invariably erosion management becomes localized, and flood management, it becomes regionalized to some degree. And so a lot of these decisions we face are really difficult. So like take the Cornish example, some of these roads that have to move, you end up with really steep wiggly roads that would then have to be upgraded to then deliver vegetables to these communities. And how do you decide which of those communities gets those roads first? Because the purse strings are not going to spread far enough. So the challenge is we have these very local planning processes, which is about real local engagement in the planning process, which is really positive. But we also need to take decisions that are a scale, one order larger than that, or two or three, in terms of how we prioritize and fund. So it's going to be very, very challenging, I think, and particularly because some areas, assets will get lost, or we may end up with some island communities that we no longer access by road because it's too expensive to maintain the roads or to rebuild the roads on steep slopes with sea level rise. How do we get back to a ferry only world potentially in 50 years time? They're all challenging. I don't have any silver bullet for that. We need to find a way of creating resource, I suppose, to have those careful conversations.
Maybe touch on some of those conversations around the well-being economy and alternative economies, like what are the values we place in society and where these fit. Good. Time for another question.
Anyone online have a question?
Anyone online? Just one at the back. You're gonna sneak in.
I was gonna ask kind of on what. So when you say like for solutions, I guess that is not so. Do you also look at other countries for that? Well, I just know I'm from the Netherlands, and like we're pretty much halfway underwater anyway. So yeah, a lot of so not solutions, but sort of for that. Maybe look at.
So there are there's a lot of work looking at can we adopt some of the practices of the Netherlands into the UK and beyond, and certainly things like the sand engine is starting to take effect elsewhere. So can you kind of prompt recovery by pumping sand to get beaches to kind of try to keep up with erosion pressures and sea level rise pressures, for example. So we absolutely can learn from these other countries, but I think it's things like the Swedish team applying the adaptation windows framework is about what governance decisions need to change in order for those things to happen. because so we need the physical examples of what they've done to the landscape, but we also need the process of how do they do it, and then how does that culturally map on to our context. I think it's quite important. But also I've had probably one of the, well, certainly a once in a career opportunity. I was in, and you never know where your career is going to go. I did a lot of media in COP, happened to be picked up by French media. I'm Canadian, so I can read French, can't speak it very well anymore. And so I was picked up by the World Bank's inspection panel to act as an advisor, which is really rare. There's been 40 of the inspections since in 30 years that have had external experts in West Africa. And there you're in a situation where you're going to hit a physical adaptation limit. And it's a completely different kettle of fish. They've moved they're rebuilding the national highway already for the third time, because the other two have fallen into the sea. And how do we change the governance structures of the multilateral banks and the lending institutions and the governments, because in some cases those landscapes will probably disappear with time. And how do we navigate that in a just and equitable way? And there's some very big challenges looming in other parts of the world around that will have effect on us in terms of the numbers of people we're expected to rehouse here, for example.
Okay, well, this leads us to thank everyone for coming, and for Larissa, of course.